The second type of circular motion is a non-uniform circular motion. In a non-uniform circular motion, the speed of the particle is increasing or sometimes it may be decreasing. It means during this circular motion, the speed of the particle do not remains the same, but it changes, that is, it may increase or it may decrease. For example, as we switch on the fan, समजा तुम्ही पंखा सुरुवात केला, पंखा सुरुवात केल्यानंतर पंख्याची स्पीड जी आहे ती वाढत जाते. म्हणजे त्याच्यामध्ये ओमेगा कॉन्स्टंट राहत नाही, ओमेगा कंटिन्युअसली इन्क्रीज होत जातो. किंवा पंखा बंद केला तर त्याची स्पीड कमी कमी होत जाते. म्हणजे या दोन्ही केसेसमध्ये ओमेगा कॉन्स्टंट राहत नाही. अशा प्रकारच्या मोशनला आपण नॉन युनिफॉर्म सर्क्युलर मोशन असं म्हणतो. It is a circular motion in which the speed of the particle or angular velocity do not remains constant. It may increase or it may decrease. If you write the example, the same example we can repeat. If we switch on the fan, it is a uniformly accelerated motion. If we switch off the fan, it is a uniformly retarded motion. So, to deduce an expression for this non-uniform circular motion, we will start from acceleration. What is meant by acceleration? Acceleration is the rate of change of angular velocity it is the rate of change of velocity with respect to time. So acceleration is the rate of change of velocity with respect to time. म्हणजे जेव्हा velocity बदलते तेव्हा acceleration निर्माण होतं. So A is equal to dv by dt. But from the cross product which we have taken in angular velocity, from that relation V is equal to omega cross r, where r is the radius and omega is angular velocity. If we substitute this value in above equation, acceleration A is equal to d by dt of omega cross r. So this is a product formula for differentiation. Using a product formula for differentiation, we will take the first term, that is omega, and differentiation of the second term, that is dr by dt, plus differentiation of the first term multiplied by second physical quantity, that is the first term, differentiation of first term, that is d omega by dt into r, that is a second term. So here acceleration A is equal to omega into dr by dt plus d omega by dt into r. But dr by dt, it is the rate of change of position vector with respect to time. Position vector gives the displacement, and as we consider the rate of change of displacement, it gives the velocity. So dr by dt, differentiation of position vector, gives the velocity, and d omega by dt, that is a rate of change of angular velocity with respect to time, is called as a angular acceleration alpha. So d omega by dt is equal to alpha. If we substitute these two values in the above equation, so acceleration A is equal to omega cross V plus alpha cross r. So this omega cross V is also acceleration, and alpha cross r is also acceleration. It means in a non-uniform circular motion, there are two accelerations. We will find the value of these two accelerations and direction of these two accelerations. So to find omega cross V, here we will find omega cross V. If we draw a circular motion in anti-clockwise direction, then omega is in upward direction and it is taken as a positive by right hand rule, and velocity is always tangential to the circular path. The third vector, apart from these two, third vector will be acceleration, because the product of omega and v gives the acceleration. To find the direction of acceleration, we have to use the right hand rule, because here three vectors, acceleration, velocity and angular velocity, they are mutually perpendicular to each other. So we have to use again a right hand rule, in which assign one vector along each finger. If we held these three fingers here, this finger, that is a forefinger, will represent the velocity. The finger which is perpendicular to the plane of the circular motion represents the omega, and third finger will represent the direction of acceleration, because the product of angular velocity and linear velocity, that product gives the acceleration. So this third finger represents the acceleration. So here this one is v, this one is omega, and this one is r. Then v is equal to, or AC is equal to, AC, this is centripetal acceleration. AC is equal to, this is omega cross v. Omega cross v. This centripetal acceleration AC is equal to omega cross v. So here omega cross v is equal to AC. So here we have find out the values of omega cross v. In a similar way, we have to find the value of alpha cross r. What is alpha? Alpha is angular acceleration and r is a radius vector. So, according to the sign conventions of angular acceleration alpha has two sign conventions. One sign convention for kinematical equation and another sign convention for the cross product. So, what is the sign convention for kinematical equation? As angular speed omega increases, alpha is taken positive. If omega decreases, alpha is taken as a negative. So these are the sign conventions which are used in the kinematical equations. But the sign conventions which are used in a cross product, what are those sign conventions? Those sign conventions are, if a particle is revolving in an anti-clockwise direction, then alpha is taken as a positive and it is taken in an upward direction. As a particle is performing anti-clockwise circular motion, alpha is in upward direction and it is taken as a positive. This is a radius vector r, which is directed from center to the circumference. Which is directed from center to the circumference, and this is a tangential acceleration, and this tangential acceleration arises due to the tangential force acting on the particle. So here again the direction of tangential acceleration is obtained by right hand rule. So stretch three fingers of right hand, forefinger, central finger and thumb mutually perpendicular to each other, and assign one physical quantity along each finger. If we held these fingers in this direction, then tangential acceleration is along this direction. This will be a negative radius vector, because this vector is directed from circumference to center, but radius vector is directed from center to circumference. So this vector is a negative radius vector and this one is alpha. We have to find the relation for tangential acceleration. Make this finger upside. Then this will be the first vector, this will be the second vector, r cross alpha. But this r is a negative. As r is a negative, we have to change the sense of cross product. That is order of cross product. Instead of taking r cross alpha, we have to take alpha cross r, and here alpha cross r is equal to tangential acceleration. So this is a tangential acceleration. So substitute these values in this equation. So AT is equal to A is equal to AT plus AC. So A is equal to AT plus AC. And here the magnitude of a vector A is equal to square root of AT square plus AR square, because these two vectors, that is AT and A, are perpendicular to each other. So magnitude of orthogonal vector is, magnitude of vector A is equal to square root of AX square plus AY square. In this way, magnitude of acceleration is equal to AT square plus AR square. So what are AT and AR? AT is the tangential acceleration which causes the change in speed of the particle. म्हणजे पार्टिकल फिरत असताना त्याची स्पीड ऑफ रिव्होल्यूशन वाढल्यामुळे, म्हणजे व्हेलॉसिटीचं मॅग्निट्यूड वाढल्यामुळं जे ॲक्सेलरेशन निर्माण होतं, त्या ॲक्सेलरेशनला आपण टँजन्शियल ॲक्सेलरेशन असं म्हणायचं. कशामुळं? त्या पार्टिकलची स्पीड ऑफ रिव्होल्यूशन वाढल्यामुळं जे ॲक्सेलरेशन निर्माण होतं त्याला आपण टँजन्शियल ॲक्सेलरेशन म्हणायचं, कारण ते ॲक्सेलरेशन टँजन्शियल फोर्समुळे निर्माण झालेला आहे. म्हणजे समजा हा पार्टिकल जर असेल आणि हा पार्टिकल असा अँटी क्लॉकवाईज डायरेक्शनमध्ये जर फिरत असेल, अँटी क्लॉकवाईज डायरेक्शनमध्ये फिरत असेल, अँटी क्लॉकवाईज डायरेक्शनमध्ये जर फिरत असेल तर हा टँजन्शियल फोर्स, हा फोर्स ऍक्ट झाल्यामुळं या पार्टिकलची स्पीड ऑफ रिव्होल्यूशन इन्क्रीज होते. म्हणजे टँजन्शियल ॲक्सेलरेशन हे स्पीड इन्क्रीज झाल्यामुळं, व्हेलॉसिटीचं मॅग्निट्यूड इन्क्रीज झाल्यामुळं निर्माण होतं. तर सेंट्रिपिटल ॲक्सेलरेशन हे केवळ त्या पार्टिकलची डायरेक्शन बदलल्यामुळे निर्माण होतं. म्हणजे या ठिकाणी या नॉन युनिफॉर्म सर्क्युलर मोशन मध्ये व्हेलॉसिटीचं मॅग्निट्यूड चेंज होतं आणि व्हेलॉसिटीची डायरेक्शन चेंज होते. मॅग्निट्यूड चेंज झाल्यामुळे जे ॲक्सेलरेशन निर्माण झालं त्याला काय म्हणायचं? टँजन्शियल ॲक्सेलरेशन. म्हणजे त्या पार्टिकलची जी व्हेलॉसिटी आहे त्याचं मॅग्निट्यूड चेंज झाल्यामुळं जे ॲक्सेलरेशन निर्माण झालं त्याला टँजन्शियल ॲक्सेलरेशन म्हणायचं. आणि पार्टिकलची डायरेक्शन बदलल्यामुळे जे ॲक्सेलरेशन निर्माण होतं त्याला रेडियल ॲक्सेलरेशन किंवा सेंट्रिपिटल ॲक्सेलरेशन असं म्हणायचं. म्हणजे सर्वात महत्त्वाची गोष्ट लक्षात ठेवण्यासारखी एकच आहे की युनिफॉर्म सर्क्युलर मोशनमध्ये एकच ॲक्सेलरेशन असतं, ते म्हणजे सेंट्रिपिटल ॲक्सेलरेशन, कारण त्या ठिकाणी टँजन्शियल फोर्स नसतो. पण नॉन युनिफॉर्म सर्क्युलर मोशनमध्ये पार्टिकलची स्पीडही बदलते, पार्टिकलची डायरेक्शनही बदलते. स्पीड बदलल्यामुळे जे ॲक्सेलरेशन निर्माण झालं त्याला आपण टँजन्शियल ॲक्सेलरेशन म्हणायचं, आणि डायरेक्शन बदलल्यामुळे जे ॲक्सेलरेशन निर्माण झालं त्याला आपण सेंट्रिपिटल ॲक्सेलरेशन असं म्हणायचं. म्हणून नॉन युनिफॉर्म सर्क्युलर मोशनमध्ये दोन प्रकारचे ॲक्सेलरेशन्स असतात, एक टँजन्शियल ॲक्सेलरेशन आणि दुसरं सेंट्रिपिटल ॲक्सेलरेशन.